think people know this.
Sit up, please. So we had rules for derivatives, we had rules for limits, we also have rules for integrals. So the first rule is if I take the integral from b to a, remember we usually start with a to b, but if I take the integral from b to a instead of a to b of f of x dx, that is the same as the negative of the integral of from a to b of f of x dx. In other words, if I switch the limits of integration, instead of integrating from b to a as opposed to a to b, that's the same as the negative of the original. So let me give you a picture to kind of show you what's going on. Alright, so if I'm going from b to a, that means that my rectangles are starting from the right and then moving to the left. So in other words, dx, my change in x, is negative. So I'll still get the same area if I integrate from the opposite direction, but this integral will be negative because all my values are negative. So I need to take the negative of the original. That will give me the integration from b to a. Are there any questions on that? Okay, good. It's a pretty handy little rule. Number 2. The integral from a to a of f of x dx equals what? Take a guess. If I'm going from a to a, in other words, I've got no...
0.
Yeah, it's 0, right? I've got really no area that I'm integrating with. As long as my limits are the same, then that area is 0. Questions on 1 or 2? This one's pretty standard. If I take the integral from a to b of k times f of x dx, that's the same as if I, just like with limits, if I take the constant out in front and integrate the function. So, k out in front of the integral from a to b of f of x dx. Hopefully that's not too mind-blowing. Okay, number 4. This is called the sum difference property. Whoa. And it says this, just like with limits, if I take the integral from a to b of f of x plus g of x, well, f of x plus or minus g of x dx, move on down here. That is the same as the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. In other words, if I've got the sum of two functions that I'm trying to integrate over, I can break them up. Okay, as this function, the integral of the first function plus the integral of the second function. Obviously it works with plus or minus. Questions on 3 or 4? Alright. This one is the additivity. And it says this, if I take the integral from a to b, or excuse me, yeah, from a to b, f of x dx, and I add on the integral from b to c of f of x dx, that is the same as the integral from a to c of f of x dx. Okay? And to kind of solidify that idea, and think it's too crazy. Okay, but suppose I had some function like this. Here is a, here's B, and here's C. And I'm looking for a couple areas. Well, basically it just says, hey, if you want the integral from A to B plus the integral from B to C, all I have to really do is integrate the function over the interval from A to C. Any questions on that idea? Okay. And last one, number 6. Domination principle. Says this: if we have f of x always greater than or equal to g of x.
Yeah, I think that's what it said.
This is not going to be good. You can pause the video there. If f of x is greater than g of x on the interval AB, then we can say this. So if that's true, this is just a double arrow, then that implies that the integral from A to B of f of x dx is greater than or equal to the integral from A to B of g of x dx. And I have a little picture here too. I have solidified this idea. So basically what we're saying is, if I take
We had a 7:30.
two functions, f and
It's
g,
late.
alright, and suppose that f is always greater than g over some interval from A to B. So let's say that we take from A to B. Well, the integral from A to B of f of x is going to be this whole thing. Right, so the integral of f of x is the whole thing. That area must be greater than the integral from A to B of g of x, or in other words, the blue shaded region. Okay? Hopefully that's not too crazy of an idea, but the orange shaded thing, the whole thing, that area has to be bigger than the area under g of x, because f of x is always greater than g of x. Any questions on the rules of integration? Definite. Nothing too earth-shattering. Okay, let's try a couple examples. In fact, I'll let you try these on your own. Suppose the following. Suppose we have this. The integral from -1 to 1 of f of x dx equals 5. The integral from 1 to 4 of f of x dx equals -2. And the integral from -1 to 1 of h of x dx equals 7. Alright, so here's some integrals. The area under the curve f of x from -1 to 1 is 5, and so on. Okay, so using that information, please do the following. Find the following. A. Find the integral from 4 to 1 of f of x dx. B. The integral from -1 to 4 of f of x dx. C. The integral from -1 to 1 of 2 times f of x plus 3 h of x
Wait.
dx. dx, and E, the integral from -1 to 4 of f of x plus h of x. Alright, so try these 5, and then we'll go through them in a minute. But try these on your own first. Okay? Remember, pay attention to the limits of integration.
Yeah,
That's going to be probably important.
This
Here we go. Letter A. The integral from 4 to 1 of f of x dx. Well, I'll just go.
2.
Yeah, it's positive 2, right? Because all I did was change the limits of integration on f of x dx, right? So if I change the limits of integration, then I just have to change the sign. I started off as -2. That's actually a positive 2. All right. Questions on A? All right. B. From -1 to 4 of f of x dx. All right. Help.
Additivity property.
Additivity property, right? I know what it is from -1 to 1. I know what it is from 1 to 4. So then this must just be 5 plus -2, which gives you 3. Okay. Okay, good. All right. This one looks like a mess. From -1 to 1 of 2 times f of x, 3 times h of x. Well, I know from -1 to 1 of f of x is 5. From -1 to 1 of h of x is 7. All right, so I think this equals 2 times 5 plus 3 times 7. And then, so what do you get? 31. Good. All right, letter D. From 0 to 1 of f of x dx. Okay, well I know from -1 to 1 is 5, so then what must the integral from 0 to 1 be? Yeah, I don't think there's enough information. We can't just assume that it's half, right? That would be, I mean, the function could do all kinds of things that would make it not half. So yeah, for this one, we don't have enough information. Not enough. Oh, it certainly exists. In fact, we know that it exists. But not enough information to figure it out. All right, next one over here, letter E. What do you got? Yes, also not enough information, right? I know from -1 to 4 of f of x, because I figured that out earlier, right, which is 3. But from -1 to 4 of h of x, I don't know. I only know from -1 to 1 of h of x. So this is also not enough info. Okay. Any questions on those?
I hope this is always
Stop it.
Yeah. No. He's done one.
All right. Next thing, we got to move on. So can I erase this?
Yeah.
Okay. It's all going to be gone.
Just gonna keep going.
You're just getting ready on the board.
How do you like anatomy?